Good morning from Auckland, New Zealand, and welcome to the part 2 of the Beginners Game Development series in Construct, which is all about animations. Today we're going to be working towards this, which we will have by the end of the session we'll have all the character animations in for the dude character in this platformer game. So you can see he's running, he idles when he stands still, he jumps, and he lands correctly. Okay, so just to give a quick idea of what sort of code would be required to get to that point, it's going to look, your events sheet in Construct would probably end up looking something like this. The only other thing I'll say before I start is with complex tasks, especially if you're a beginner, it's always a good idea to have maybe like a checklist or a list of tasks to do, so you can break it down into smaller pieces. You don't have to hold all that in your mind as you go. So you might, for example, like I've done here, use a Google Doc, maybe Google Keep, some sort of checklist to keep track of the things that you're gonna work on. Okay, so that's just an example, but you can create your own. All right, let's get into it, So starting from where we left off in the last tutorial, let's go to Construct again, and we will open the part one, the end of part one tutorial. So we start from the same place. Okie dokie. So we have the scene, an empty event sheet, and remember that what he looks like. He doesn't have any animation, so it just looks a bit strange. Okay. Right, let's get into it then. I'm going to look at my little checklist off screen. Okay, so first thing we're going to do is to work on the player's idle animation, right? So as we've done before, we're going to open the sprites animation editor by double clicking on it, and then we're going to load animations from the menu. We're going to browse to in the GitHub repo that's posted in the description of this video. Browse to sprites and then dude, and we'll add in the dude idle animation. Import from strip, and of course we need to know how many frames there were in the animation. So I'm going to quickly get back into that folder so you can see. We can check how many frames there are. So here we go, just bringing that on screen. Here's the dude idle animation, and here's the actual image. And we appear to have 4, 8, 12, and 15. 15 frames. That looks good enough to me. So we'll set that correctly, and horizontal, of course. And we've imported all the frames of the idle animation. We'll rename it just to be consistent for the next few tasks. And of course we need to do all the little tweaks that we've done to the single frame in the previous episode. So we are going to fit the bounding box, so we can apply that to all frames in the animation, apply to animation, and that will crop the bounding box to every frame in the animation. So that's a quick way to do that. We also are going to check the colliders. Now this collider and the others don't look particularly sane at the moment, so we're going to just fit them to the bounding box for simplicity's sake. Okay, so we right click, set to bounding box, and then it becomes a rectangle, and of course we're going to apply that to the whole animation as well. So if we right click again and go to apply to whole animation, then all the bounding boxes are ready as well. Sorry, the colliders. Last thing to do that we have to do on each frame is obviously place the origin so that he's centered around the same point in each frame. Otherwise you might sort of jump around during the frames. So we're going to put the origin between his feet in the middle, roughly in the middle of his character, and we're going to go that one by one, just putting the origin at the bottom of his feet. Okay. And in the middle of the screen. Okay. So 15 frames is a lot. Usually with an animation or a simple animation, you might not have quite as many frames. It's a smooth animation this way. Hey Dad? Dad's come in to grab some food from the fridge. Okay, yeah, just picking up. So yeah, on the idle animation, last thing we want to do is just check that it's looping. It carries on, it repeats. And we might want to change the speed. We'll come back to that. So we're going to test this now and see how it looks, right? So it's not working at all. That's because I forgot to set the initial animation on the character sprite. So here we go. We'll set the idle animation to the initial one, rerun it. Okay, he's moving and he's idling. Probably he just looks a bit slow there. So let's just speed up that animation slightly. Yeah, let's double it. You know, the rule of thumb is when you're changing speeds, double or halve them just to get a noticeable effect, and then you can refine it afterwards. So we'll set that to 10. That's doubling it and see what happens. Yeah, maybe it looks a little bit fast. It looks alright. I'll just tweak that to 8, and then we'll be done with it. Okay. Cool. Let's run that again. Yeah, it looks roughly right, eh? So yeah, the only other thing I could show you there is I forgot to mention that when you're in the animation editor, of course you can preview the animation right here just by clicking this preview button here. That'll show you at least that it's not jumping all over the place and that the speed is about right. So that's another way to check it. Yeah, so that's done. I'm just clicking through my checklist of things. All right, so the next thing we're going to do is add the run animation. So in the editor, let's do this again. So we're going to load animations from file. Now the same folder, in the same dude folder, we're going to go to the run animation. Of course, I need to check import from strip. I need to check how many frames there are before we start. So this will be run, and we have 1, 2, 3, 4, 8, 10 frames. Okie dokie, 10 frames. It always seems to get them wrong by just one number. Anyway, interesting. So we're going to do the same again. We're going to fix the bounding box for every frame in the animation. We're going to rename it as well. We'll rename it to run. Okay. We're going to look at the colliders, and of course they're all whack. So zoom out with control, move around just by using the wheel, etc. on your mouse or trackpad. And right click, set to bounding box, and then right click again to apply to the whole animation. So you can double check they're all correct. That looks great. Now we're going to set the origins, and this one's a little bit more interesting than we've done before. I'll show you why in a moment, but roughly again set the origin to his just under his feet in the middle of his body for each frame. That's, you know, it gets a bit more interesting, you can see, because he's leaning forward, so roughly that's the center of him. We carry on doing this. It doesn't have to be perfect, right? You can tweak it afterwards. That looks about right. This one, so okay, this is the interesting frame, right? So in this frame, he's actually off the ground. He is in the middle of a sort of a, yeah, he's running off the ground, right? So that means the ground won't be here at the same level. It won't be in line with his foot. The ground would be, say, there, like slightly below his feet, right? So let's put that there for now, and we'll see how it looks later. He's back on the ground now, so we can go back to putting them on the bottom of, near the bottom of his feet. And we're almost done. This is a nice smooth animation, so it's got lots of frames again. Yep, looks good. And this is another jumping one. So again, we'll put it in the center of him, but like, you know, roughly, oops, that was auto-saving. Just check at those 2 frames where we've put it underneath the bounding box. Let's sort of check that they're roughly the same. That looks about right. Let's preview it and see what happens, eh? So we're going to press preview, and you can see it's not looping for a start, which makes it slightly more awkward to view. So we'll loop it, and then we press play, and it looks like he's running at about the right height. Like you can see his head stays at about the right place during the bound where he's above the ground. So I'd say that's about right. The only thing I would do maybe is increase the speed which just happened to go to 7, which I think is probably about right. Yeah, maybe 8. Let's go to 8. Okay, cool. Great. Yeah, that looks great to me. Okay, we'll exit. Okay, and then we got to test this, right? Now what's going to happen? Of course, it's not going to do quite what we want because something's missing. We haven't programmed in the actual change to that animation. We need to actually set that animation at some point in code. But first, let's just have a quick look at some software design principles to get you started, because it helps if you understand what's going on in the background. So the first thing to understand is this concept of a game loop. So am I actually, yeah, there we go. So the game loop is a software design pattern used in game dev mainly, and it's part of the engine. So it's not code that you'll have to write yourself, but it's running in the background. And what happens is, this is a very basic example of a game loop. What's happening in the loop is it might be checking for input from your keyboard or controller, and then it goes and checks, and then it goes and runs the game logic that you've written. So that would be the a filled in or completed event sheet. In this case, it's your code, and then I wish I hadn't zoomed out now. Let's try this again. Yeah, there we go. And then the next thing it's going to do is draw everything to screen. So just to reiterate, so in the game logic, that's where everything, including a player and enemy, animations and physics and score text, etc., get updated. So you change things in the code and they get drawn to screen in step 3. That loop runs over and over again in the background, and you don't have to worry about writing any of that yourself. It runs at roughly 30 frames per second in construct, which is just interesting to know in case you start to see performance issues, because 30 frames per second is kind of the limit. If you go below that, so if you've got too many things happening on screen, then you start to see problems, like things glitching, things not moving correctly, etc. Right, so moving quickly on from that. Just a question at the bottom here though. Does this code always run in the same order, and why not? So this is an interesting point with code in general, but also construct events, right? So in this case, this code won't be always run in order, and that's because each of these lines of code are actually event-driven code, and that's symbolized by the green arrows. So they will be triggered, or they will run whenever that task or trigger actually happens. So for example, when the game first loads and the character sprite is created, then the animation would be set to idle, but not during the game itself. Or again, like when the character sprite moves, so platform on move, that's the behavior platform on move, then the animation should be set to run. But that would only be happening when the character is actually moving. Okay, so they can happen in any order basically. Right, so that does bring us to the event-driven code, right? So as I mentioned, you've got the green arrows indicate that it's an event-driven code. They're triggered in response to input after important tasks by the engine. So again, it's something you don't have to worry about coding yourself. You just have to write these lines of code that handle the actual event. They execute exactly when the event occurs, when the trigger occurs. The event keyword is on. So if you ever see a condition with the word on in it, like platform on moved, that means it's an event, and indicated with a green arrow, like I said. Lastly, the order does not matter because they execute when the triggers occur. Okay, so then that means that there is another type of code, which is sequential code, which is indicated at the top there. So sequential code executes every cycle of the game loop. So whether something is happening or not, that code will be executed. So for example, in this one, you've got when the keyboard left arrow is held down, then set this character sprite to mirrored, so that will be changing his face left or right. That will be checked every time that game loop runs. not just when the key is initially pressed. And of course, if you were to change, not perhaps in this example, but if you had more complex code and change the order of some of those lines, that would affect, that possibly would affect the outcomes. That's something to be aware of. The order matters with sequential code. Okie dokie, that was a lot of talking, so let's just get back into the code, So I'm going to now add the run animation for when the player moves, right? So remember, at the moment he doesn't actually run, so we're going to start by adding an event, and we're going to add the condition is going to be on character movement. So we're going to add the condition for the character, which is that he's moving, right, or that he is starting to move. So that would be an event trigger. So it starts with on, and it's going to be this one here. You can search for all the conditions you want. It's just something you get used to. You actually get used to the names of them after a while. So when the character is moved, on moved is the event trigger, and we want the action to occur again on the same character sprite that the animation is set, right? So if we search animation and we go to set animation, then we can type the name of the animation that we had in our animation editor earlier and click done. Okay, so let's go back to the layout and check what happens now. So he runs. He's also falling through the ground, but he's running and he's not stopping, right? So there's a few other things we need to put in here, but we're getting somewhere. Okay, so the next thing is when he stops, we want the animation to go back to idle, of course. So we're going to add the next event. So again, on the character sprite, when he stops, so it's the platform behavior animation triggers. See platform behavior animation trigger. So on stopped, then we want the character's animation to be set to what? To idle. Okay, cool. And then let's try that. So he runs very fast, and then he stops and goes into idle. So that's great. Now we can see another problem here is that when he goes backwards, he's still running in the same direction. So we'll have to fix that. Okay, so where have we got to? So let's fix up his direction on, let's fix up his running direction when he goes backwards, okay? So this is going to be a sequential code, not event code like before. So we're still looking at the character sprite. We want, sorry, no, we're not. No, we're going to look at the keyboard. So in this case, we need to look at the keyboard input in order to determine which way this character is going to be facing. So first thing we're going to do is right-click, insert object. We're going to add a keyboard object just to the scene. It's not an actual object that you can interact with in the game, but it's a controller in the project. Okay, so that's in the project now. So now when we add an event, we see that there's a keyboard object to select from for the condition, and we want to, when a key is down on, when a certain key is pressed, when it's held down, that's what we want to change its direction on. So we're going to select that, and we're going to click to that, and then press the left key to start with. Okay, so when the left arrow is pressed, that's the condition. Now we're going to add that he gets mirrored, because that flips him around the vertical axis. So set mirrored, and we want him to be mirrored, correct, right? So while we're here, let's do the opposite, right? So there's a quick way to do that, which is you can select the whole piece of code just by clicking in there, not anywhere else, because that's not where we want. We want to copy the whole line, and we hold it Control to copy it, or Control C and Control V, and we have a similar line, except this time we want this condition to be when the right arrow is pressed, right? And done. And of course, we don't want it to be facing left anymore. We want it to be not mirrored, so that's facing right. Okay, so that should complete his directional facing. So he runs now, and now he turns left and he runs. He's still falling through the ground, which is a little bit disconcerting. And there we go. All right. Next thing is his jumping animation. So let's add his jumping animation now. So we go back to layout. We open the sprite editor again. We're going to add again. We're going to add a new animation. This time we're looking at his jump animation, which is a nice and short one. I can see that's only 3 frames, so that's great. Okay. And now we need to do the usual. So we're going to crop every frame in the animation. Just double check it. We're going to set the colliders correctly. Well, we're going to set them to the bounding box, and we're going to apply that to the whole animation. Great. Yep. And then of course we're going to set his origin. So, and this time again under his feet. Okay, this one's slightly different. When he jumps in this animation, he's also under the control of the platform behavior. So when he jumps, he actually lifts off the ground as a part of the platform behavior. So you don't need to put a gap between his feet and the origin on this one. That will be taken care of for the fact that he is lifted off the ground by the behavior. And in the last origin there, we will rename it, of course, to, I pressed F2 to rename, so that's going to be called run. Oh no, it's going to be called jump. We'll delete that one because it's redundant now. And we'll preview this to see what it looks like. Oh, that was strange. Hey, look at that. There's a problem here with the origin because it wouldn't jump around unless there was. So let's just have a quick look. The second frame, the origin click didn't register for some reason. So yeah, okay. And just to clarify this, we don't want this one to loop because we want it to, when he's flying through the air, we only want him to hold that last frame before he hits the ground. And the speed, we'll adjust that in a moment. So if we preview that, it's kind of hard to tell, isn't it, because it's so small. Probably looks a bit slow, as with the other frames. Let's just set it to speed 8 and be done with it, I think. Yeah, that looks good. Okay, we'll jump back into the layout, press play. Well, we know what's going to happen. We're going to press play and the run animation, the jump animation, of course, won't activate because we need to program it with the event sheet. So here we have, we need to set the jump animation on that platform jump behavior. So again, the character sprite is the condition object, and then we're going to be looking for a platform event, again, not sequential code, but on jump is the event because you just want it to happen once when you press the up key. And then add the action of character behavior, setting animation, the sprite action to set the animation, again to jump this time. Okay, and we'll preview this, we'll test this. So he jumps, and of course he lands, and he doesn't go back to idle. That's the next thing to fix. So we're going to need a little bit of teaching here. So we've done sequential code now because we've done the keyboard left and right, and now we want to look at a bit of conditional programming. So if you've ever programmed before, you probably don't need to watch this, but if you're just learning, then here we go. So conditional statements, those are the if-else statements that you might have seen before or heard of. They basically evaluate a logical expression, and a logical expression is shown in construct as the condition here. Each of these evaluates, and then we obviously run the action based on that logical expression. Each of those logical expressions evaluates the true or false. So if it's true, then the action is run. If it's false, the action does not run, and the next line of code will be run. Okay, so in those logical expressions, they're usually indicated with the word is. And so, for example, the left keyboard arrow is down. And if you do see an else statement, or you want to use an else statement, that just means that this line here, this else action, will only be run if this line's logical expression evaluated to false. If this line runs, then this line would not be run because it's an else. So it's like saying if something, do that, otherwise do that. Okay. Yeah, that's all I want to say about that. Let's just leave it at that. So we'll come back to our event sheet, and we're going to need now to add in some conditional code, because the problem we're seeing is that when he lands on the ground, he doesn't, the animation does not get set back to idle. So what we're going to do is we're going to add an event again. So on the character's platforming behavior landed, then we're going to add this action that he should set the animation to idle, which is the beginning, but not the complete functionality, right? So if we run that, so when he lands, he goes back to idle, except that when he's moving through the air and lands, he doesn't, and he also falls off screen, but bugger game, whatever. Okay, so this indicates that we're going to need a bit more logic. We're going to need to use a conditional statement here, right? And one other thing to know is that you can combine them. You can use sub-events to combine other conditions, right? So in this example, sub-events appear indented. So these are sub-events right here. So they occur after the initial event has resulted, after the initial event has evaluated to true. So in this case, if the sprite platform lands, then and only then these sub-events will be run. So again, they are conditions. So if the sprite platform is moving, then you're going to set it to run. Otherwise, you're going to set the animation to idle. Yeah, roughly sub-events, they allow you to evaluate multiple logical expressions. They also, the first one must evaluate to true, as I've explained. They're extremely useful with event-driven code. Remember, the green arrow indicates that's event-driven code. So that's pretty much what we're going to have to do. So in order to do that, you need to select the whole line here. You need to right-click on it and go add a sub-event. Okay, and then in this case, it's going to be, and here we want to know whether the character is moving. So if the character is moving, then we're going to set the animation action. We're going to set the animation to run, right? Because we want him to run as soon as he lands, rather than stand there and idly slide across the screen. And then, so yeah, as we've seen, when the character hits the ground and he's still moving, we want the animation to be set to run. If anything else happens when he hits the ground, so i.e. he just lands on the spot, then we want to set the animation to idle. So that's going to be our else condition in this case. In order to add the else, is a little bit awkward here, but we're going to right click on the top condition. We're going to add the condition as a sub-event here. Add sub-event. This time it's going to be a system sub-event, and we go to else. And this time we want the animation again to be set to idle. So we'll just type that in here, and that's almost correct. We're going to take out this action here because this was just to get things rolling. It wasn't complete. Let's play and see what happens. So he still idles when he hits the ground now, so that's great. And when he hits the ground running, he actually runs. Okay, great. So that's all for animations and your first taste of coding in Construct. We'll see you in the next episode.